Good morning everyone. So recall that in the last class we have discussed hypergeometric equation, which is x1 minus xy double dash plus c minus a plus b plus 1 xy dash minus aby is equal to 0, where a, b, c are constants. And then we discussed, since here x is equal to 0 and x is equal to 1 are regular singular points, so we discussed their solution about x is equal to 0 and x is equal to 1. So solution has been written in the form of f of a comma b comma c comma x. In this form, the solution are known as hypergeometric series solution. Their expansion has already been discussed in the last class. Now to proceed further, you need to remember the hypergeometric equation and its solutions about x is equal to 0 and x is equal to 1. Now we want to find the hypergeometric series solutions for a given differential equation, which is of the form x minus a x minus b y double dash plus c plus dx y dash plus ey is equal to 0. Clearly a and b, capital A and B, are regular singular point for equation 1, and there are some other conditions such that a should not be equal to b, d should not be equal to 0. Now in the last class also we have seen that when we have to find the solution about x is equal to 1, then we introduce an independent variable t which is equal to 1 minus x. In general also, the given equation 1 can be transformed into an hypergeometric equation using the substitution t is equal to x minus a by b minus a. And it's clearly visible why it works, because for equation 1 I need the hypergeometric series solution about x is equal to a and x is equal to b. For t, if I put x is equal to a, so here for x is equal to a, you can clearly see that t is equal to 0. And equation 2 is hypergeometric equation, so I know that its solution about t is equal to 0. And for x is equal to b, t is equal to 1. So I know the solution about t is equal to 0 and t is equal to 1. Therefore, this substitution works, and you can easily try by yourself that if you substitute t like this, it gets transformed into an hypergeometric equation. Now let's see some exercises based on this concept. So we begin with the first exercise, 2x square plus 2x y double dash plus 1 plus 5x y dash plus y is equal to 0 about x is equal to 0. I don't have to find the Frobenius series solution. Frobenius series solutions of the form summation a naught summation a n x raised to the power n plus r, and hypergeometric series solutions of the form f of a comma b comma c comma x. Okay, so to find the hypergeometric series solution of this equation about x is equal to 0, first we have to see that it should be of the form of equation 1. So equation 1 is x minus a x minus b. So that's why I can write it down as, I have to divide the whole equation by 2 and it becomes x plus 1 y double dash plus 1 by 2 plus 5 by 2x y dash plus 1 by 2y is equal to 0. Yes, now you can observe here that there are two choices for a and b. Either a is equal to 0 and b is equal to minus 1, or you can take a is equal to minus 1, b is equal to 0. If you take this as a is equal to 0, b is equal to minus 1, then t is equal to x minus a, so x minus 0 divided by b minus a, so which is divided by minus 1, which is minus x. Here t is equal to x minus a, so x plus 1 divided by b minus a, which is 1. Yes, both are acceptable. The only observation is, if I am looking for the solution about x is equal to 0, so when x is equal to 0, your t is 0 and vice versa. Yes, it means when the given equation get transformed into hypergeometric equation, then I have to pick the solution about t is equal to 0. Yes, and in this case when I put t is equal to 1, then x is equal to 0. So if I choose t is equal to x plus 1, then I have to take the solution about t is equal to 1. So that's why we discuss both the solution about x is equal to 0, about x is equal to 1. So this is very important to remember. Generally, I prefer to consider the solution about x is equal to 0 because it has a little bit of less computation than the other one. The other remark is that for the given equation, x is equal to 0 and x is equal to minus 1 are regular singular point. It means I can find the hypergeometric series solution about x is equal to 0 as well as about x is equal to minus 1. But here it has only been asked about x is equal to 0. So if I consider t is equal to minus x, then my dy by dx is equal to dy by dt multiplied by dt by dx. Now dt by dx is minus 1 because if you differentiate t with respect to x, it becomes minus 1. So minus dy by dt. Now d2y by dx square is d by dx of minus dy by dt, which is minus d by dt of, I use the chain rule and I wrote d by dx as d by dt by dx. Now dt by dx is minus 1, so this becomes d2t by dx square. Now I substitute the values of x, y dash and y double dash into this equation. So let's say this is equation 2, this is equation 1. So equation 2 would become, so equation 2 is x plus 1, so x is minus t plus 1 d2y by dt square plus half minus 5 by 2t minus dy by dt plus 1 by 2y is equal to 0. Yes. Now I need it in the hypergeometric form, which is x, if you see the hypergeometric form, t1 minus t. So I want in this form only. So that's why I multiply it by minus 1. So it will become t1 minus t d2y by dt square, and this minus will become plus, so plus 1 by 2 minus 5 by 2t dy by dt minus 1 by 2y is equal to 0. Now if you compare it with hypergeometric equation, then this is your c. So c is equal to half a plus b plus 1 is equal to 5 by 2 and ab is equal to half. Yes. Now you can solve a plus b plus 1 is equal to 5 by 2 and ab is equal to half. But by clear observation also, if you choose a is equal to 1 and b is equal to half, or you can choose a is equal to half, b is equal to 1, because f of a b c x is same as f of b a c x. So this will satisfy both the conditions, and now you can write down the solution about t is equal to 0. So about t is equal to 0, your solution is y of t, which is c1 f of a b c t plus c2 t raised to the power 1 minus c, a minus c plus 1, b minus c plus 1, 2 minus c and t. So your y of x is c1. Now a is 1, b is half, c is half, t is minus x plus c2 minus x raised to the power 1 by 2, f of 1, 3 by 2, 3 by 2 and minus x, which is the required answer. So you can observe that it's quite easy to find the hypergeometric series solution. Let's do one more exercise. So x square minus x minus 6 y double dash plus 5 plus 3x y dash plus y is equal to 0 about x is equal to 3. Please do try it by yourself first. So if I have to write it in the form of x minus a x minus b, then I must write it down as x minus 3x plus 2 and rest remains as it is. Now again I have both the choices for a and b. So if I choose a is equal to 3 and b is equal to minus 2, then my t is x minus 3 by minus 5, or I can write x is equal to minus 5t plus 3. That gives me dy by dx is minus 1 by 5 dy by dt, and d2y by dx square is 1 by 25 d2y by dt square. Now substituting, please do try to substitute by yourself and simplify it. See, it is guaranteed that you must get an hypergeometric equation. If you are not getting the hypergeometric, it means that you may have done some calculation error. So for the obtained hypergeometric equation, a plus b plus 1 is equal to 3, ab is equal to 1, this is minus y, and that gives you a is equal to b is equal to 1. So t is equal to 0 means x is equal to 3, and therefore my y is c1 1 1 a b c, and this is t, which is x minus 3 by minus 5 plus c2 x minus 3 by minus 5. So this is how you obtain the hypergeometric series solution. So that's all from this section. Thank you very much.